Hello everybody, this is Goran
And Eloi Andalus
from Effective TDs.
Yeah.
And recently we posted a video on Facebook.
A little controversial video.
We created some heat.
Yes, we had a lot of replies. Someone banned me from Facebook.
Really?
Yeah.
Oh wow.
Yeah.
So
Losing friend. Well, it was not even a friend, but yeah, I don't know. People get very sensitive with some subjects.
Alright, well, people take it personal. Anyways, we decided that we want to create a second video that goes a little bit deeper into it and maybe take out some heat by explaining and comparing actually the grain solvers that Houdini has and the software that Effective TD has on their website, the Storm. So Storm is a grain solver, and that's basically all it does. And obviously Houdini is a full 3D package containing pretty much anything you can imagine. So
we compare grains in Storm with grains in Houdini.
Exactly. And we actually compared the Vellum and also the old grain solver.
Yeah, because if you saw the video, we was doing it with Vellum in Houdini,
Yeah.
default values.
So you basically, all you did is you just used the shelf tools.
Yes, I play a little with it, but I see that
Right.
to improve it, I had to increase time, so I keep it default values.
Yeah.
There is ways, obviously, that like we will see that we can improve it a little, but what we found right now is that the old grain solver, in fact, is way more stable than
Right.
Vellum grains.
Correct. So basically what happens, we dig a little bit deeper into it, and when you create a Vellum grain solver, it by default sets the substeps to 5, and also the constraint iterations are at 100. So to match that to the old grain solver, basically the old grain solver creates sets substeps to 10 by default in the pop solver. So we basically took the grain substeps, set it to 5, and we took the constraint iterations from Vellum and set it to 20, because that's what the old grain solver has by default.
Yes, to match it in some way.
Exactly. Now let's have a look at the results first, and then also let's have a look at the speeds afterwards. So looking at the results, we have the Vellum here, and basically it does the simulation. It is a little bit explosive, and there's quite a lot of sliding going on, which we probably can reduce by increasing the friction on the collider. The explosions that we found, they come from
Repulsion.
the repulsion, which is by default set to 10,000, but at the same time, if you reduce it, you get less of interparticle collisions.
Yeah, you can see them getting compressed and then expanding, and it's doing kind of a weird
Right.
stuff.
So we'll leave this setting here, but yeah. And then we have the old grain solver, which gives us a much more stable result, much less explosions, and the collisions are fairly similar. Everything pretty much slides down. So again, with some friction, I think we could fix that with a few iterations. And then let's compare the Storm result, which is also just out of the box, 5 collision iterations, and we can see a very stable result. Very nice kind of frictiony sliding, and here also a really nice pile up, which we get here, but much less, obviously, because the particles are being pushed away and slide away. So maybe there's just a much higher friction by default on the ground.
This can change.
Okay. Now, fairly similar results out of the box, except for Vellum, we had to change some stuff, but that's nothing that is very important. Okay, now let's have a look at the times. Let me stop this playback. Is it still playing? Because we're here on a laptop. Actually, let's talk about the specifications quickly.
Yeah, this can be important. We are doing this on a laptop. It's an i7 6700 HQ. and we have a GTX 960M.
Where's the stuff?
I don't think it's there.
Windows is constantly changing stuff.
Device? System?
Yeah, that's what I did.
No.
So, about. Here we go. Okay, so we have i7 6700. And then does it say what the graphics card is?
Normally not there, but it's a GTX 960M.
Is that an NVIDIA or AMD?
NVIDIA.
Okay. GTX 960.
Yeah.
Alright.
One thing that we have to say is that the Storm is full CPU.
Correct.
And Houdini Vellum is using GPU. Grains, we have OpenCL enabled as well.
Yeah, by default. So
by default.
basically Houdini sims are on the GPU while the Storm simulation is on the CPU.
If we compare, if we force Houdini CPU, here a Storm is like 4 times faster using CPU to CPU.
I think that was a wild guess, but
we can try it, but right. Seriously, but
it's slower. But let's.
But the thing here is that we use totally 2 different things.
Yeah.
So maybe if you have a much better graphic card, then you will get better performance in Houdini.
If your graphics card is much faster than your CPU.
There is things that can influence quite a lot.
Of course. But this is our current setup, and let's have a look. So if I hit play on Storm, we can see we have roughly about 11 steps per second, and since we have 5 subsamples, that gives us 2 frames per second. Right?
Yeah.
Did I calculate that correctly?
No, it's good. Another thing that we have to say is that the Storm is displaying all sub-steps. Correct. So it looks much more fluid because Houdini shows you the full frame.
Yeah.
So it doesn't show you the 5 sub-steps while
but that also means the GPU is calculating 5 times the image, which if you turn that off, like for example on the farm, you're going to get even a higher speed up because the GPU doesn't have to do that.
Yes.
Okay. So, but yeah, it's pretty consistently at 10 subsamples. Okay, here it gets a little slower, but it jumps back up. So that's roughly 2 frames per second. So let's reset that. Now let's go to Houdini. And here we are in the Vellum setup. Oh, maybe I should mention how many particles we have.
We had in both systems roughly 70,000.
77, 76.
76,000.
Okay, so 76,590 in Storm. And then if we look at our grain simulation, so here we have our Vellum source. We have 77, so 1,000 points more. And then here we have even 78, which is even more, but okay. So, all right, let's give it
funny thing
a little bit more room. So
funny thing we had is that even we have the same grain size in the pop grain solver than in Vellum.
Yeah,
it gives different numbers of particles.
Yeah, so the way these 2 nodes are creating particles
is different.
And obviously Storm as well. But we're kind of roughly in the same numbers.
Yeah.
All right, so let's have a look at Vellum first. So we go inside, we display everything. And as I said before, so if we do, where was it?
Repulsion or?
No, the...
In common.
Here. So if we put that to default, so this is basically what Shelf Tool sets when you create Vellum grain solver. And if we put that, so we get 53 frames
per minute.
Frames.
Yes.
So
we need to divide that by 60, so we will get...
Why by 60?
60 seconds in a minute.
I see.
Yes.
Pretty good.
So we will get frames per second.
Yeah,
and
0.9 or something.
0.9.
0.8. Whatever. Pretty, like less than a frame per second.
But the worst thing is that by default, we get a lot of explosions on the grains. You will start seeing now on the right part, full of grains exploding. There is ways to fix that, obviously. But
yeah, it's an inconvenience. So you get a lot of stuff exploding for whatever reason, doesn't matter. But now let's go and put that to the grain settings, so we put that to 20. And what else did we do?
On advanced, we found that we decreasing
Oh.
max acceleration. This clamps the velocity, so we don't have so much explosion.
Yeah, I see that, yes.
And we can decrease the repulsion.
Well, let's leave the repulsion because it gives us nice interparticle collisions. Okay, so now we get 1.1 frames per second, which is pretty good. It's still roughly half the speed of a storm in this case. Okay.
And we get rid of...
Did we?
They
came pretty late.
There is still, you can see that still we have some particles going out.
Just go crazy.
Things that we can do to fix that is to add some attraction force, then change the look.
But that's not a solution to me because the look itself changes.
There were some people pointing out that, but
we want to keep the look. Like you can't compromise the look. If some VFX soup comes and says like, no, I want dry sand, you can't just do that. So, anyways,
obviously the only solution here will be to increase substeps, so we will get not exploding particles, but then timings will go up.
Another one will be just to really limit velocities, to say never go faster than this. But that is up to, like you have to start tweaking. Anyway, so now let's have a look at grains itself. And as mentioned before, we have 20 collision iterations, and by default it just sets and we set it to 5. By default it set it to 10 subsamples, but we set it to 5 to match Vellum and to match Storm. So now if we hit play on this, it's a little faster than even with more particles, it's still a little faster than Vellum. And it doesn't do exploding particles. So there must be some kind of settings that side effects put into Vellum that might be, subject to improve. But it's a new part of Houdini, so I'm sure they're gonna adjust that sooner or later. Okay, so in general, we are like by half a frame per second slower than in Storm, as it looks. Now, obviously, we can improve this by not showing the collider, and the time jumps up a little bit.
But then we can do the same as well in Storm.
Right, and then we get much faster times.
Something that I can point out is that if you try to rotate the view now while simulating, it's a small. It's kind of laggy. And in a Storm, while we are simulating, you can move kind of fluid your screen. Because doesn't make a big difference, I know, but it's something.
Actually, wait. So I have to. There you go.
Yeah, the thing is that a Storm is CPU, so you have the GPU free to move totally smooth.
Well, I would still like to see Storm integrating a GPU solver to see if that
would be
the code
awesome.
That it runs is even faster on the GPU.
Yeah,
that would be very interesting. But anyways, all the tools are like pretty good, but clearly here Storm wins the race, but in speed. But it probably loses it with all the options that it has compared to Houdini.
Yeah, obviously Houdini is a much more complex software, and with grains in Vellum you get all the different types of constraints that we are a little more limited in a Storm. But if you need simple sun, snow interaction with a rigid body, it's a pretty valid solution. And
so I hope this sheds some light on all this whatever it was. But I think Storm is a pretty cool tool. It's developed by our friend Sebastian Schäfer.
Amazing job that he did, and
I just did that on the side
to be done by one simple developer. He did that over the last 3 years, but it's pretty impressive.
And from what I hear, there's more stuff to come.
There is a lot more stuff coming.
I hope you guys like this. I hope you guys give it a try. It's a pretty cool tool. It's very simple, but it does a really good job. So
and the idea is to be super straightforward. So obviously we lack a lot of stuff from Houdini, but you do a setup in literally 2 minutes. You have something up and running, and it's easy to adjust. export with PRTs, bin files, Alembic files to import on any software. So
Okay, so but I have another question, Eloi.
yes.
So what's the deal with this naked dude?
I don't know. I was thinking you would like it.
Ah, right. Yeah, good. It has some. No, it doesn't. Look at this. No.
Come on.
All right, guys. Hope you liked this presentation and
Yeah.
give Storm a shot. It's a pretty cool tool.
Thank you so much.
Thanks, guys.
See ya.